The metal lathes in the student shop are Harrison Model M300s, equipped with Sony digital readouts. In operation, a lathe spins a piece of material, called a part, about an axis of rotation. Stationary cutting objects, such as cutting tools, drill bits, and reamers, are brought into contact with the spinning part to shape it. The cuts made with a lathe are all radially symmetric. The direction parallel to the axis of rotation is the Z direction, or the carriage direction. Holes can only be drilled in the carriage direction along the axis of rotation. The direction perpendicular to the axis of rotation is the X direction, or cross direction. Cuts can be made in the carriage direction, in the cross direction, or in some compound direction between the two. The piece of the lathe that holds and spins the part is called the chuck. The jaws of the chuck are adjusted to hold onto or to release the part with the chuck key. The lathe cannot be operated until the chuck key has been removed and the chuck guard lowered. Please do not leave the chuck key in the chuck after using the lathe. Again, you must have the chuck guard down to turn on the lathe. The tool used to cut away material is mounted in a tool holder. The tool holder is then locked into position on the tool post. Cutting tools have different sizes and shapes for cutting different profiles in the part. There should be at least 4 tools with different sized radius tips for each lathe. The radius of the end of the cutting tool determines the radius at the end of the cut. Be sure to place the tool in the tool holder in the proper orientation. Each tool has a top that is clearly marked with the radius of the tool. The tool goes into the tool holder in the orientation shown. Be sure that the cutting edge of the tool is not sticking out too far from the tool holder, or the tool may break. Mike, who makes the tools, and the other students who need to use the tool do not appreciate broken tools. Tighten the hex bolts snugly with an Allen wrench or hex key to keep the tool from moving during operation. The height adjust hex bolt on the bottom of the tool holder must be properly adjusted for the lathe to cut properly. The lever on the tool post locks the tool holder in place. The edge of the cutting tool must be at the exact mid-height of the part for the tool to cut properly. A simple technique to adjust the height of the tool uses a piece of sheet metal or a scale. Place the sheet metal between the tool and the part and lightly move the tool up against the sheet metal and the part. Adjust the height of the tool until the sheet metal is vertical. The tailstock sits opposite the chuck and is able to move freely along the length of the lathe. The long black lever locks the tailstock in position, and the back wheel moves the mount of the tailstock in and out. The drill chuck, which holds drill bits, starter bits, and reamers, is the most common tool used in the tailstock. To mount the chuck in the tailstock, first, wipe off the smooth surface of the back of the chuck to remove any debris, then slide it into the mount. Notice the mount should not be all the way back to allow the chuck to fit properly. To remove the chuck, rotate the back wheel to move the mount back until the chuck is released. There is no locking mechanism to keep the chuck in place. It's simply an airtight fit. The other tool which is used in the tailstock is the Lathe center. The head of the Lathe center rotates and is used to support the loose end of long parts. 3 wheels control the position of the tool. The carriage hand wheel, which moves the tool along the spinning axis of the lathe, or the Z direction. The cross thread hand wheel, which moves the tool perpendicular to the spinning axis, or in the X direction or cross direction. And the compound hand wheel, which moves at a user-specified angle with respect to the other two axes. If you use the compound hand wheel, be sure to reset it when you finish. Move it back until the dovetails are flush to protect them. The angle of the compound hand wheel can be changed by loosening the nuts on either side of the mount. There are two places the angle can be read from, the side or front of the base. Once the angle has been changed, readjust the position of the tool post so that it is perpendicular to the carriage of the lathe. Each of the wheels has some play in them, so the hand wheels can move a little without moving the position of the tool post. When adjusting the wheels, try to always approach a desired position of the tool from the same side. This will ensure greater accuracy with the machine. The spinning speed of the lathe can be adjusted with the two chuck speed control knobs. Faster is not always better. To change the speed, push in the knob and turn it. If the knob doesn't fall into position, rotate the chuck a little to get the gears to line up. Follow the lines that the white dots on the knobs line up with to read the speed of the lathe. The lathe is equipped with an auto feed to automatically turn either the carriage wheel or the cross feed wheel at a constant velocity. The auto feed direction and speed controls are all the knobs under the chuck speed knobs. The white dot on each speed knob points to a letter or number. These letters and number are used to read the auto feed speed off of the table next to the speed controls. The direction knob controls if auto feed will go in or out. The arrow to the left indicates feed into the part. The arrow to the right indicates feed away from the part. Again, the white dot indicates the position of the knob. Under the cross-feed hand wheel is the carriage cross-feed selector. As indicated by the markings on either side of the selector, the out position selects the cross-feed and the in position selects carriage feed. The lever below the feed selector is the auto feed on-off switch. Up is on, down is off. The digital readout on the lathe can be used to determine the position of the tool and changes in the position. However, you should always measure final dimensions with a micrometer or calipers, as the digital readout is not perfectly calibrated. Press the on button to turn the readout on. Press the reset buttons for the readout to operate. The reset buttons will also set the readout to 0 for a given dimension at any time. You can also set the readout to a specified number. Press the button indicating which readout you wish to set, enter the desired number, and press the P button. The X readout displays the position of the cutter in the cross-feed direction. The X readout reads in diameter. This means that if you move the cutter 20 thousandths into the part, the readout will say you moved 40 thousandths, indicating the change in the part's diameter. The Z readout displays your position in the carriage direction. It measures changes in the carriage direction directly. To turn on the power to the lathe, you must turn on the breaker on the wall next to the lathe you wish to use. This will turn on the white power light on the lathe. The big red button next to the power light is the emergency off switch. Pressing this button will turn the lathe off. To resume operation of the lathe, twist the button until it releases. The red lever on the carriage turns on the motor of the lathe. To turn on the motor in the forward direction, pull the lever out and down. To turn it on in the backward direction, pull the lever out and up. The foot brake on the lathe will turn off the lathe and slow it down quickly. To resume operation after pushing on the brake, move the direction lever to the neutral position first and then set it to the proper direction. When shaping a part on the lathe, the first operation is to face it off. Facing off a part gives the part an end that is flat and square to the axis of rotation. In facing off a part, you should not need to take off very much material. You face off the part by placing the tool in slightly from the end of the part and feeding the tool in the cross direction, either by hand or by using the auto feed. The auto feed will always give you a superior finish. Be sure that the height of the tool is at the exact center of the part. In this first example, the tool is not properly centered and leaves a little knob of metal in the face of the part. The knob can be eliminated by centering the tool properly and then facing again. Most of the operations with the cutting tool can be done either with the hand wheels or with the auto feed. The auto feed will always give you a better finish. Additionally, the slower the auto feed setting, the better the finish. It's often fastest to use the hand wheel for the initial cuts and the auto feed for the final cut. Note the face quality of this acrylic faced with the auto feed. Once the part is faced, you'll want to zero the position of the tool. To zero the position of the tool, lightly touch the tip of the cutter to the part in the direction desired and press reset. If desired, you can instead set a specified reading on the digital readout for that direction. Repeat for the other direction. A common operation, such as on the hammerhead, is to reduce the diameter of the part from the front edge to some location further down the part, and to have a round or fillet from the reduction to the outside edge. For this common operation, position the cutting edge of the tool such that when it is moved into the part in the Z direction, it will cut off a small amount of material. The amount you should take off per cutting pass depends on things like what kind of material you are cutting, how fast the part is spinning, and how fast you want to finish the operation. Try starting with 10/1000ths per pass and go from there. The auto feed should be used on the last cut to get a good finish. The radius of the fillet at the end of the cut is the same radius as the cutter. Although it's not demonstrated here, you'll want to stop the lathe and measure the part with a micrometer or calipers when you get close to the desired diameter, instead of simply trusting the digital readout. Common advice in the shop is that you can always cut it smaller, but you can't cut it bigger. Another common operation on the lathe is to create a cone-shaped feature in a part. This is done using the compound hand wheel. The auto feed cannot be used for this operation. Set the tool post to the desired half angle of the cone. In other words, if the cone has an angle of 20 degrees, set the post to 10 degrees. Move the tool close to the part and use the compound hand wheel to move the cutter into the part at the desired angle. Return the cutter to the starting position with the compound wheel and then use the cross-feed wheel to move the cutter deeper into the material for each successive pass. Keep in mind that the more material the cutter removes per pass, the worse the finish and the hotter the cutter will get. Be especially careful at the end of the cut. It's easy to move too fast and burn the material at the bottom of the fillet. There are several types of hole that can be made in the end of a faced piece. A drilled hole, a threaded hole, and a reamed hole. Any of these can also be countersunk. All three hole types begin the same way. A starter bit is placed in the chuck in the tailstock. A starter bit is relatively thick with a small drill end sticking out. It will not flex when the hole is started, so the position of the hole is quite exact. The starter bit is used to drill a pilot hole, which is a short hole used to guide a full-sized drill bit to the center of the piece. You advance the bit by turning the wheel on the end of the tailstock. After the pilot hole is drilled, you put the drill bit corresponding to the desired hole size in the chuck in the tailstock. You then advance the bit by turning the wheel on the end of the tailstock. The depth of a hole is measured from the face to the end of the full diameter section. It's not measured to the deepest point in the hole. Oil is rarely needed when drilling holes, and the quality of the hole will be higher if you don't use oil. Using more bits than the starter bit and the final diameter bit to drill a hole will usually make the hole walls less smooth and make the whole axis less square. Do not use a series of bits to drill and enlarge a hole. For a tapped hole, after you've used the starter bit and the drill bit, you'll want to use a tap and a spring-loaded tap guide to tap the hole. The tap guide holds the tap centered on the hole and perpendicular to the part. While tapping, do not turn the lathe on. Great unpleasantness will follow if you do. You may need to step on the brake to keep the part from turning. Bring the tailstock forward and use the tap guide to apply a small amount of pressure on the tap. Then screw the tap into the part. You should use a small amount of tapping fluid to help the tap turn easily. As the tap enters the part, be sure to keep the tap guide in contact with the tap to keep everything square. A properly reamed hole has a much tighter tolerance than a drilled hole. The first two steps for a reamed hole are the same as for a drilled or tapped hole. First, drill a small pilot hole with the starter bit. Second, drill a hole slightly smaller than the desired final size. The third step is to use the reamer to create the final size of the hole. Place the reamer in the chuck in the tailstock. Then advance the reamer as if it were a drill bit. If the reamer is making a lot of noise, some oil may help. Stop short of the end of the drilled hole. To repeat, do not push the reamer all the way to the end of the drilled hole. If the reamer pushes against the end of the hole, it will flex enough to change the hole size by as much as 10,000ths, and the resulting hole is not a precision hole. A final common operation on a lathe is to file a part to shape. It is possible, but time-consuming, to create a spherical end on a part with repeated cuts with a cutting tool. However, it is much faster to file the part into shape. To file a part, use a large file so that your hands are as far away from the chuck as possible. The black spot on that thumb is from getting too close to the chuck and being hit by one of the jaws. Move the file as if the part was not rotating to prevent the teeth from being worn off the file. Be careful of slipping off the part. Be patient. It may take a while to finish. For the final finish on a curved end, use sandpaper and something with a properly sized curved surface. When you have finished with the lathe, be sure to restore everything to its proper place and clean up. Remove any of your cuttings in the area down below and make sure to vacuum up debris that has landed on the floor.
That just brings the sharpness. Should always.
So we've run a little long this morning, but I think we've learned a lot.
What's the test?
If you want. So.